Hello guys, to another video. So in this video I will be teaching you how to design the layout of a CMOS two-stage operational amplifier. So this is the schematic that we had designed in the previous videos. So now let us go ahead and launch Layout Excel. So in Layout Excel you can also go to launch Layout L, which is a little better than Layout Excel. So you can go to File, Open the Opamp schematic here. Yeah. So now we can start off with these two PMOSs of 15 micron and 1 micron length. So go ahead and instantiate an PMOS. And length is 1 micron, and I've given the body type as detached. So we have one more PMOS of same dimensions. So here, as you can observe in the schematic, that these two nodes are shorted. So what I can do in the layout is, instead of drawing a metal one from here to here, I can directly overlap the two devices like this. So this shared node becomes VDD, and this is one node and this is the other. You can label them, press L, we can label them for our reference and delete them later. So we can label this node as X1, this node as X2, and this as X3, and this as X3. So what happens is I have shared VDD between them, and the other two nodes, that is the left and the right are X1 and X2. So now let us place the two NMOSs. So the width is 3 microns. So coming to these two, as you can see here, X3 is again common, so we can overlap them. So it becomes X1. So it becomes X1, X3, X2. X1, X3, X2. So now let us place these two NMOSs, width of 4.5 microns. So we can just copy this and place it here and change these properties 4.5 micron. Now coming to this, as you can see, one side is IDC, VSS, X3. So again here VSS is common, so we can share that as well. Place them perfectly on top of each other. So it is X3 VSS and then IDC. So it is X3 VSS and IDC. Now coming to these two, it is nothing but a common source amplifier. So let us instantiate a PMOS and a NMOS. So its length is 50 microns and the NMOS length is 10 microns. So let us level them. Okay, so now let us proceed with the connections. So the gate of the two PMOSs are shorted. So this poly and this poly have to be shorted. So you can go ahead and place a M1 to poly, and you can also increase the rows. Make sure not to go too close to DRC error. So we have shorted these two terminals, and now X1 is also shorted to the gate. So this is X1 that is also shorted to the gate. So we can do that using metal 1. So coming to the NMOS, this is X3 VSS IDC. So IDC two transistors. So again these two gates are shorted, and it is shorted via metal 1 to IDC. So let us go ahead and do the connections. So these two gates are IDC, and it is shorted via metal 1 to this node. Let us draw metal 1. So now coming to these two transistors, the drains are shorted, which forms the output. So let us short the drain. So let us short the drains using metal 1. So this becomes the output node. And coming to these two transistors, the gate of one NMOS is V1, the other is V2. So this is V1 and this is V2. So let us go ahead and place M1 to PO. And short them using poly. So the V1 and V2 connections are done. So now IDC is also going to the gate of this NMOS. So IDC must also go to this gate. So we need to use a metal 1 to poly again. Here it is also going to that gate. So we can route it using metal 1. So now let us move on to the next connections. The gate of this PMOS is coming from X2. So let us locate X2 in the layout. So this is X1 VDD X2. So this should be going to the gate of this transistor. So that is again we have to place a metal 1 to poly via. And draw metal 1 path. And increase the width slightly. So that this connection is done. So let us check with what we are left with. So we are left with X3 connection. So this is X3 and also this node is X3. So it is X3 VSS IDC. X3 VSS IDC. So we need to short these two nodes. We can do that using metal 1 again. Draw path. So the X3s have been shorted. And now we are left with the VDD and VSS connections. So let us go ahead and mark which is VDD here. So this center is VDD and also this is VDD. So we can short them using metal 1. This is also VDD. So short it using metal 1 as well. So as you can see, they are not properly overlapped. So now to avoid a DRC error over here, we can fill this gap up with an implant. So draw a rectangle of an implant. Do the same with P implant. Yeah. So now we are left with placing pins and VSS connections. So let us identify the VSS here. So this is VSS. So this is VSS, and also this node X3 VSS IDC. So we have to short this and this, and also give a body connection. So we can go to parameter body type as detached, and we get a VSS connection. So we have to short all these using metal 1. So that connection is done. Now let us place the pins. Press Ctrl P. Now let us start with VDD and VSS. For that, first choose metal 1 pin that is available here. This is VDD and this is VSS, and this is Vout. This is IDC. And these two gates are V1 and V2. So I think we have done with all the connections. So let us go ahead and perform the DRC and LVS checks. So we are faced with off-grid errors. So let us resolve them. Off-grid meaning, as you can see, this yellow square jump from one point to another. If a poly lies between them, we are faced with off-grid errors. So make sure that does not happen, and we have to resolve that. So moving on to the next errors. So looks like the off-grid errors have been solved, I think. Now coming to the stamp errors. So the poly to oxide spacing is greater than 0.2 microns. So make sure not to put the poly very close to the oxide. So seems like we have missed a connection with x1 and x2. So go ahead and make this as detached as well. Now coming to this connection, the x1 of the PMOS is shorted with the x1 of NMOS. So this is x1 and this is also x1. So you have to short them using metal 1. And this is x2. So it is x1, x3, x2, x1, x3 and x1, x3 and x2. Let us close the previous run and run it again. Okay, so it's saying that this distance must be less than 10, but it is slightly more than 10. So you can move your entire design to the right a bit. Okay, so let us go ahead and make it detached here again and short the VSS. So now there is error seeing a body connection. Yeah. So now moving on to LVS. To make sure all the connections that we have performed in the layout matches that of the schematic, we are running LVS. Yeah. So the LVS and the pins that we have placed and also the interconnects are perfect and they completely match with the schematic. So as you can see in this dialog box, the schematic and layout match. So this is what you have to get. So these connections and all these connections are in sync and they are perfect. So the Opamp layout has been designed. So this is not yet a very optimized design, I can say. Coming to the advanced VLSI design, we will try to minimize the wastage of area, and also since it is an analog block, we will provide appropriate shielding so that it does not get affected by the circuits around it. So this is it guys for the layout of an two-stage CMOS operational amplifier. So I hope to see you guys in the upcoming videos, which will be related to more advanced topics and also deal with how to optimize these circuits further. So let me know down in the comments below if you guys are interested. I will definitely make more videos and also post the errors that you get. I will help you solve them. So thank you guys. Stay tuned.